So our group is doing peak and accidents, and we're also analyzing the morning and evening rush.
So our hypothesis was that
so our first hypothesis is establishing standard traffic curve and peaks by detecting detection of certain minimum deviations and potential indication of car accidents. And our second hypothesis is we also know that traffic will be congested during morning peak hours and evening peak hours.
So the definition of peaks is like a periodic increase in traffic density. It usually happens during rush hours, hence the name rush hour peaks. And some may be caused by accidents. And the estimated delays of the buses on the highways is around 150% to 350%. And traffic incidents and accidents, they are unpredictable, and they are significant traffic densities and will hang around for quite some time, like say half an hour or so. And there's a possibility that it gets stuck permanently, and the usual delay is around 400% or above.
Alright, so this is our original data that we used to make our graphs. We used a couple methods to turn our data into like readable format. So first we got we plotted the delay according to time of day. So for example, during our AM graph, we would show 6:30 to 10, and on the y-axis we would show the delay percentage, or how long you would be delayed. So for example, 30 minutes. If we go back, basically this is the time we would plot it on the bottom, and then here would be the percentage delay, and then we would do an average, and we would plot it against a certain time of day, so like AM or PM, and weekends, weekdays.
The averaging was over what? We just verified the other one?
We were averaging the delay percentage time.
We averaged 5 days we average on weekdays, and we also average on weekends. We separate them so.
Because weekends and weekdays have drastic changes in the traffic routes and predictability.
And then the other way that we analyzed was, well, for the first hypothesis was that we looked at weekends and weekdays, but we also looked for specific things in the graphs.
So as we can see on these two graphs, we see two peaks. So as we can guess, there's a correlation between these two graphs. They appear at around the same time, towards the evening. However, we can, there's a high chance these are actually accidents that cause these abnormal peak rush hours, as you said. As you can see on this graph, the delay percentage is extremely high, of over 400%. And on this one, there is a peak, which might be the rush hour peak, and then a second abnormal peak, which might be caused to an accident, which causes additional delay.
What we then looked at was a compilation of all the weekdays from July 24th to 30th, so it was excluding July 27th and 28th. And if we look at them all together, we can see an average peak time around 4:30, 4 p.m. We also see the graph that Alex just mentioned in the previous slide, this purple one, I believe, and the peak, it starts to increase earlier, so that could be a potential sign of an accident. But in this case, if we look at the date, it's actually July 26th, and that's a Friday. And so in this case, after looking at it, we determined that it was actually because on Fridays, many people leave the city going out on the 401 eastbound out of the city for the weekend. The second one on the weekends it was basically constant, the amount of delays. It never really surpassed the average time. There was a bit of delays near 12 p.m. and that was on Saturday when most people start going out after waking up late. And then on Sunday, it was relatively constant as well.
Yeah, so this data analysis was on the DVP, northbound and southbound roads on the weekends and in the mornings. So as we can see, the graph shows that the percentage of the delay is below 100%, indicating that there was actually negative delay, which is actually the traffic on the roads, excuse me, was actually lesser than it was supposed to be during the average timings. So what could be implemented is to divert traffic or to encourage people to use the DVP, northbound and southbound roads during these early hours, which would help a lot.
Okay, so here are the PM times for the DVP north and south. As you can see, it's kind of different from the AM times, because if you didn't see in the previous slide, south was actually higher than north. But this could be a cause of perhaps people working overtime and going north to go home. But it can also be a cause of people going to cottages and taking DVP north to go to their cottage homes, stuff like that. And as you can see here, the north is a lot higher because, well, it's a weekend. No one's really going into the downtown area. And as you can see by the percentages in the bottom graph, it normally stays at 100, meaning there's no delay, if not even less delay. Oh, and we chose the DVP because it's one of the most busiest highway parts of the GTA, because it leads straight into Toronto, and as well as most major highways such as the 401 and 404 go into the DVP, causing a lot of congestion.
So this is the weekdays data for AM. Here you can see that during the AM for this is in minutes, like how long you're being delayed. So during the around 6 o'clock or something, not many people have waken up yet, so it's kind of negative delay. But as people start to wake up and then they're heading downtown for work, so before 9, which is roughly when companies start, there's a high amount of congestion because people are heading into downtown. So most of the roads are kind of congested. And if we look at the percentage part, it's actually 200% or higher, which basically means that a lot of congestion is happening and that the road is very blocked.
So as you saw in the previous graph, DVP southbound was actually really congested because it was in the AM and everyone was coming downtown. Well, in PM it was vice versa. DVP northbound had extremely high congestion, up to past 300%, while southbound remained constant around 100%, so which is normal. So we conclude that the traffic is congested during mornings driving southbound and evenings driving northbound. As you see in this picture, we notice one problem is if the lanes are even on both sides, in the mornings driving southbound will be highly congested, while the other side will be have almost no cars, and in the evenings it will be vice versa. So our solution to this is to have reversible lanes. Oops, sorry. Where in the morning there's given 8 lanes. In the morning, 6 lanes will be going southbound, and in the evening, 6 lanes will be going northbound. This ensures the maximum usage of our resources, and it improves the flow of traffic throughout the entire day.
Well, okay, so identifying traffic incidents, this can help detect and divert users to other roads in case, other highways in case one highway is down. So to detect car accidents, we can just analyze the graphs and see and record data as it goes, and we can see the delay, and we can see that something's happening in the highway that's abnormal. We can use cameras, preferably bird's eye view cameras, with software that can identify whether there's a crash. For example, so if you look at the car from above, and there's 2 cars here, and it will somehow identify the edge of the car, and mark it as a hitbox, and if it detects a collision if the hitboxes actually collide. So also to detect traffic jams, we can use light gates at different sections, so you can measure the speeds of the cars easily. And with light gates, if there's multiple cars going at the same time and it's really slow, it blocks it off completely, so you can't record the speed that quickly, so it will be longer, it will be slower, so you know there's a jam easily with light gates. And so yeah, if optimal speeds is bigger, like if the actual speed is smaller than the optimal speed, then there is a jam. We can connect all these components, the cameras and the light gates, to the cloud, the computers in the cloud, and we can use the cloud to alert users via radio, social media, and road message displays. In examples such as Hong Kong, if you go near a highway or a tunnel, your radio gets you can say it's hijacked. Basically, a management company basically broadcasts message through this radio, through certain radio frequencies, and if you're on your phone or if you're listening to radio, it'll get blocked off, but you can see these messages immediately. You can hear it. Yeah. Thanks.
Also, a last thing. Well, we made a website sort of to we didn't. No, I can actually just go because it changed the content.
I can open what you gave me.
Okay. Well, we didn't have a lot of time, like maybe an hour or so. But we just did a website, put our data on it, did a small introduction to our team, etc. Because we were told it was sort of optional. I actually changed some things on the.
Can you tell us what you have?
Well, actually, I know. Is it better if I actually go into it and go on the site now?
Change the name.
No, sorry. I just changed a couple of things and actually made it set up. Let's go. It's 54.25.76.247. Is that divide it and go research? Yeah. Okay. So, as I said, just a quick introduction. Some data which somehow one of the charts disappeared. Alright. With a couple of the graphs and that we had shown in our presentation. As I said, we didn't have a lot of time, so we didn't manage to put results in or our analysis of how to connect to the cloud. But we managed to put some stuff, and at the end we put some sources.
How does displaying this type of data from a smart infrastructure perspective optimize the performance?
Well, it's on the website, we'll just
on the website. So if
On
you're
the
getting
website.
data, if you're doing analysis of that data and providing the results in real time, let's say,
on the website.
on a website,
Well, it's if you organize it well on the website, it's much easier to
what does it do? How do you change the performance with that?
change performance. Well, it depends.
The performance of the highway.
Yeah.
So basically, you see these peaks, and if it goes to a certain level, you just broadcast the message through the cloud, and you tell the users to go to other highways instead of optimizing the usage themselves.
Yes.
Like,
So who would be doing the action then?
If it's
software in
displayed-
the cloud.
Well, if it's displayed on a website, there would probably be a human on the other end as well.
You
So
can
the
have,
action actually here is done by the human being.
you can
If
do
it's
human
on a
being
website.
or software.
Or software.
It's
Any questions for the group?
go.
Your 8-lane highway idea where you switch the lanes according to rush hour, how would you separate the northbound, southbound lanes to like avoid like a head-on collision?
They'll have like lights on every single lane, and for suppose in the mornings going southbound, all 6 lanes will have like an arrow pointing southbound, while the other side would have an X, so you know you cannot go on the other side. And in the evenings we switch. So.
But what if there's an accident? Like the concrete barriers that we have on the 401 and whatever, those will stop cars from like going onto the side that's coming this way. So how would you do that?
It was the same thing as any normal highway. You have the lines in between, and
I mean, certainly there's a higher risk, but it's already been implemented in a couple areas, just like on bridges or things like that.
like it's been implemented
Yeah.
in many countries.
Yeah.
Does it work?
Yeah,
Like in Calgary,
it
there's
actually works. Yeah, I mean, if you trust the people on highways to actually be sober and think about where they're driving, then it should work. But as you said, yes, there's a high risk.
Wouldn't it be like counterproductive because if you have no protection, there's going to be a higher amount of accidents, which means a higher amount of jams.
There's
Um,
going to be protection.
Actually,
it doesn't mean there's a higher amount of accidents. People drive more. Like most of the accidents are done by certain drivers, and it depends on the people. Plus, it's been implemented in Calgary and it's working perfectly fine and improves traffic for the entire day.
and anyway, in general, the advantages are bigger because you will reduce basically the delay time for morning and evening peaks, whilst an accident wouldn't happen every day, or every morning and every evening.
Just to add to that, if you didn't see when we were showing the reverse lane, the image that it showed, the center lane, or at least there was at least one lane that wasn't being used, and that was in case of such accidents because they would So you see right here, there's that lane that's no cars on it. That would be a safety lane. So if they would not use that lane for either side, just as a precaution.
Great. Any more questions for the group?
Questions kind of similar, but like, why would you say like 6 lanes going and the other way? Like, why did you come up with this good collaboration? Are there like?
Oh, the 62 is actually an example, but we plan to having sensors and for like a full entire month or so to detect how many cars go each direction and find an average. So we set the amount of lanes to each side depending on our results.
So you can optimize the lanes accordingly over time.
The good thing with this system is it's very flexible, so we can change from 5 to 3.
It is pretty smart, but then there is a delay because you're collecting data and optimizing as you go, and you have to look at the data. Like the software has to see it before they can optimize it.
And also you mentioned the example of the Calgary, is it on a highway or just like looks like they're like a whole highway? Because there's not a whole highway that goes up like a certain road system is different.
Well, it's like one road to go down going through downtown, and it passes over a bridge too. The speed limit is actually around 60 kilometers per hour, so it's not too fast, which is why there's not a lot of accidents either. And it's actually 4 lanes, but I believe it can be implemented in cities such as Toronto.
Well, there was the Jarvis Road where this was implemented, but it was free time, so in the afternoon it would switch going north, and in the morning it would switch to go south.
How will this work for, will this at all be implemented for larger highways? Because certainly at least, certain way highways are designed, like sometimes you need to be in the left-hand most lane of your side of the freeway if you want to get it onto a certain interchange to the next freeway. So how would that work if like, oh, you can't get over because now traffic's going the other way, what are you going to do about it? How are you going to fix that?
There will be a set time that you know when the lanes was changed. Like it's not gonna change randomly any time, depending on traffic.
So it would just be that, so you know that you can't get on the freeway, so you need to take an alternate route.
Before you get onto the highway, it would already start like blocking, like it would start dividing the road accordingly. So you will know as soon as you hit the highway, or
so
you
your
will be
normal
at
routes need to be changed at that point. So it is.
Unless we don't implement this.
and also you can use the clouds, you can broadcast messages to users before when they get near it, because if you use radio frequencies, you can have a certain.
Yes, but I'm still saying people who have their own set of ways of traveling places now will need to change it up because of this.
No.
Well, no.
It's never going to be, suppose it's 8 lanes, suppose. It's never going to be 8 going one way and 0 going the other. It's at least there's always few lanes.
But like, if it's just the right-hand most 2 that are going one way and 6 going the other,
Right.
but usually it's 4 and 4.
Yep.
Sometimes the 2 most left-hand lanes will go off, say like, to go off onto, I'm just going to
Where?
use,
Like
I mean,
the opposite lanes beside it. Opposite lanes beside it, so you never get to go left.
Yeah, but that's the thing. Okay, I'm just going to use LA Freeway as an example. So you're going on you're going on the 2 south. There are 2 ways you can go: 134 east or 134 west. On 134 east are in the right hand most 2 lanes. 134 west are on the left hand most 2 lanes. Let's say you want to go on 34 west, but because 2 northbound has more traffic, those 2 lanes are now blocked up. How are you going to get onto 134 west?
We never block off a complete.
Yeah, on like most
No. What you're saying is you just
when you're exiting the highway, you just add another lane.
So this isn't exiting highway. This is an interchange.
yeah.
Well,
You
yeah.
would block off the whole.
So wait.
What are you trying to say?
So it's 4 lanes going this way and 4 lanes going the other way. And let's say you've got 6 and 2 now. Usually there would be an interchange off here for the 134, but now traffic is coming this way to stop it. So how? But usually because of the barrier, you can get onto that freeway interchange no problem.
So from the remaining lanes, you just add another exit, which would do that change to go west.
So it's more construction of that.
Of course. Of course.
But I think
A lot more construction.
such construction is far more easier than adding 2 more lanes on each side, or even like 4 more lanes on each side.
No, I get that, but it's the fact that you're building an entirely new off-ramp and
Yeah,
I mean, it's a lot
additional
of
off-ramp
construction.
is needed to be built. Yeah. Also, if you're saying like there's a road like interchanging right in the middle of there, you can use these like in Hong Kong the tunnels. They divide the lanes up. They sometimes have lanes in the middle which are empty. They use these portable roadblocks and you just move it around, and you can have like one section that is open and you can just go back up or go down.
Okay, are there any more questions? Yeah, be loud, please.
Just want to say from the construction's perspective, adding like if you're going to expand the technical term is actually called grade separation, like the intersection of 2 highways. That construction is not as easy as you would probably think, because it is subjected to many geometry constraints, and also like the concrete stuff. So it is. I feel like it's something that you guys should probably think about. Also, like if you're widening that part and then you're coming back to a highway, you're actually producing a bottleneck. You know what I'm saying? Like especially like when people when they drive like on the grade separation, like their speed has to go slower because of that the curvature.
But we're not going to implement this in every single road. Like we're going to find the major roads where it's feasible, and it's like the most feasible ones. That would be
the most where it would be most effective, of course.
And
It's not a perfect system, so we can't put it everywhere.
And also, this is aiming to like improve the morning and evening rush hours. So basically, we change the middle, like we widen and decrease the lanes when it's not rush hours. So there would be less cars, and you can use like there would be less risk if you want to change it. There will be less bottleneck.
Okay, we'll have to stop the discussion here. Let's thank the group for their presentation.
So I'd like to say a few words in terms of your presentations. First of all, I'd like to congratulate you all, because in 1 week you accomplished a lot in terms of learning, in terms of just sitting on the side there listening to your discussion. It's clear that by and large you got it in terms of the issues in relation to transportation systems, and in particular intelligent transportation systems. But the other comment I wanted to make is that within the context of the DEEP program and getting a sense of what engineering is about, most of the time for the large complex projects, there's never an easy answer, okay? And yet engineers routinely, that's their job, to design systems, large systems, okay? And so you have to make decisions. And what you got was a little taste of some of what goes on when you're doing engineering design, in the sense that there's aspects that have to do with people, okay? So there was a talk in terms of psychological impacts, okay? That's very real, okay? There were impacts in terms of congestion, Okay, there's groups that make it their business to quantify what the cost to a region is for the traffic delays, what the cost in productivity, and they basically put it down in dollars. And there's also some glaring what were they thinking kind of moments here. The team that was talking about 407, okay? Yeah, then when that government decided to privatize that highway, I remember thinking, what are they doing, right? And we're still living with that mistake, right? So the point being that engineering it's not just the technical part, okay? Engineering has to do with people, it has to do with society, it has to do with politics, right? If you read the papers at all, you keep reading about Rob Ford and subways, right? These are real questions, okay? And you can say that your discussions today were kind of theoretical, okay, or hypothetical, but in the real world, these are there all the time, okay? And in terms of how do engineers make their decisions, okay, well, they do what you did. They gather data, okay? They do quantitative analysis. They argue, okay? My model, your model. But the idea is that it's done on a quantitative basis, and if done right, it's based on reality. It's based on real numbers. Were you the one talking about the cross correlations?
Yeah.
Okay, you do that stuff, and it tells you a lot. It really does. Okay, it tells you about what factors are important, what's causal, what causes something or other, and engineering brings all of these tools together to make decisions, and hopefully good decisions for society. So anyway, so I congratulate you all. I think your week was well spent, and I pass you back. I congratulate the two instructors as well. Thank you.